Are there yet still unknown currents in the Arctic Ocean? Well, recent radioactive isotopes have indeed located never described before hidden Arctic currents. Hello friends, Jim here. So what is going on? Well, so we've got a photo. The Canadian Coast Guard ship, the Louis S. Saint Laurent, over here on the right, you can see a helipad there, is collecting samples of iodine and uranium. Well, what's that all about? Hang on. The Arctic Ocean is warming 4 times faster than the rest of the world's oceans. Okay? We know that the Arctic itself, region-wide, is warming 4 times faster than the rest of the planet, some locations 5 times faster. But for the oceans, the Arctic Ocean itself, to be warming 4 times faster than the rest of the world's oceans, that's huge. Yes, the Arctic Ocean is not a very large body when compared to the Atlantic, Indian, and Pacific. But think of the specific heat involved to do so, to accomplish a 4 times warming, and what that heat means to the sea ice diffusing to the atmosphere, which is being measured. That is a huge amount. Now, of course, it's aided by the fact that there's inflow through Fram and the Bering, from the Atlantic and Pacific sides, but still, that is significant. So it's warming 4 times faster than the rest of the world's oceans. It's a trend that could potentially spill over to the rest of the world in the form of altered weather patterns and other climate consequences. And, you affect what the heat's diffused to the atmosphere, impacts cloud formation, and so forth. Efforts such as Synoptic Arctic Survey are studying the Arctic Ocean to better understand ocean currents, so hoping to better project what future changes might be in store. And don't forget, you got the loss of the albedo. That means instead of reflectance of the sun energy, which can then lead to cloud formation, you have absorption of the sun energy that tends to not lead to cloud formation. And of course, a lot depends on the air temperature and the season. One way to track ocean currents is by tracing or tracking radioactive isotopes that humans began generating in the 1950s during nuclear testing. Radioactive isotopes. Who does that remind you of? Yes, indeed, Wally Broker. Wally Broker wrote the seminal book called Tracers in the Sea, where he uses radioactive isotopes, radionuclides, to not only trace water movement of the ocean, but also to identify water masses and to then examine when water masses meet and interact, what takes place at those events, what's the mixing, and so forth. This is all building on what Wally Broker did. So what they're also noting is that nuclear reprocessing plants are still releasing iodine-129 and uranium-236 into the Atlantic. And that's what this ship is measuring. In a study published in the Journal of Geophysics Research, Oceans, Annabelle Payne and colleagues used these radionuclides present in very small but still traceable quantities to learn about the decades-long path that water from the Atlantic Ocean takes into the Arctic Ocean's Canada Basin. Their work analyzes radionuclide levels in samples from the deep Canada Basin that were gathered in the 2020 Beaufort Gyra Observing System Joint Ocean Ice Study Expedition. And you might have seen the acronym JOISE, JOISE. That's Joint Ocean Ice Study Expedition. So when you see JOISE or JOISE, that's what it is. The researchers found that the water flowing into the Canada Basin takes two separate paths. One across the Chukchi Plateau and Northwind Ridge, and one that follows the perimeter of the Chukchi Plateau. Basically, think of the perimeter of the Chukchi Plateau as sort of like the shelf break where the bathymetry then dives down to the basin. Additionally, they found that about 25 to 40% of winter water from the Pacific Ocean contains markers of Atlantic water by the time it reaches the Canada Basin. That's mixing. That is mixing. And they attribute this to upwelling on the Alaskan Beaufort Shelf or in Barrow Canyon along the boundary of the Chukchi and Beaufort Seas. Now, the Barrow Canyon is off of Point Barrow, which is now called Utqiagvik. The town's been officially renamed, so Barrow is now Utqiagvik. But there's a canyon right off that point there. That's Barrow Canyon. That's kind of the boundary between the Chukchi and the Beaufort Seas and the Chukchi Plateau. So if they're finding markers of Atlantic water that are upwelling, we know Atlantic water is warm water coming in. That's what? That's upwelling warmer waters to the surface to do what? You guessed it. Melt the ice, prevent the ice from forming. Comparing their results to previous studies, they note that transit times for Atlantic waters into the Arctic have not changed over the past 15 years, indicating the currents have been stable over that period. This research helps validate that iodine-129, uranium-236 are useful traces for tracking water masses in the Arctic Ocean, presents a high-resolution glimpse of currents in the region. Another tool to help us understand better the processes taking place in the Arctic Ocean basin. But keep that in mind. The importance of that upwelling of that Atlantic water, that it's warmer, that helps melt the ice. So we've got another mechanism. But don't forget, that water comes in as intermediate water, but what then happens to it is it flows around. There is some mixing and some diffusion, but now we have an actual physical mechanism, an upwelling, basically Ekman pumping into shallower layers that will contribute to melting the sea ice and delaying sea ice formation later in the year. It would be interesting to see how this information will add to the work that Rebecca Woodgate and her team and her colleagues are doing. And you've heard me discuss her research as well. So this is interesting, really interesting. We'll talk soon.